Hey folks, this is a reference video for the wilkiedb distributed database system. I'm going to give a quick overview of a save file I'm about to upload here in a minute. So first I'm just going to go over where everything is and what it is, and then I'll do a quick walkthrough of how the flow works and what the significant parts are. So over here are order retrieval stations. So you'll see these in your production facilities especially. So each one has some order info about which items it's requesting, and then also some namespace metadata. And yeah, some loading logic here, the general store here. So this is for taking that order data and making it available to the red-green network here. And so this has 8 of these loading stations, and it just has little infinity chests that make the order go away, so that it has to get retrieved more. Once it runs out, it goes over here to the reception station, and here it reads the train ID, then asks the station what the order was for that train, and each train stores its ID down here, which also becomes available to the network if it queries that train ID. And then whenever it docks, it stores that again. And then after the reception station looks up the order, it goes from green to yellow back to green there, and then it forwards the order over the screen wire, and then it begins loading it by requesting the items and then putting them in. Then there's a little corrector arm here that pulls out any items that are too much or from the train that isn't part of the order, so it doesn't like overflow with having too many items there from before. And yeah, and then so this is the minified version over here, and then over here is the dev version. These are identical otherwise, and I have it kind of running active here, so you can see it behaves the same. You can chop off the kind of knees of these to prevent them from being used if you want to force the trains to go over to this one. And then up here is the dump trains. So these are the requester loader trains, and these are the dump trains. So between them is the storage facilities here, and there's not many here because there's only a few items that are in this this kind of test version. But you can put as many items as you want, and they'll get stored here. And a lot of the time you'll see them go straight from the dump train to the requesting train, and just skip these boxes entirely, and that's because the purple boxes take priority over the yellow boxes. So the idea is that the warehouse is sort of like a generalized store that any number of trains sending items or exporting items can send to without having to make a special station for it or whatever. And then likewise, any other station can, or any other satellite station can make a requester station here and then retrieve items from the warehouse. And again, the dev version is over here. And if you want to take a quick look at how the train schedule works for the dump trains, these are just let's see, these here are just for the testing stuff, and there's a waiting, you'll probably want a waiting station, but it's not necessary. And then warehouse unloading is the actual one. You'd want to do green signal greater than 1 and 1 second event activity so that you can do refueling and stuff. There's some refueling stuff in there. And then there's 2 queries going on here. So one of them is retrieving the order data for a specific train as it comes in and docks. And this one is a general query that retrieves all order data, because this one's looking for 0 equals 101. And if you look at these, they're all 0 101, 0 101, 0 101. So that means this one matches everything. So when it gets back, it runs every like 10 seconds, whatever. This gets up to 600. Yeah, right again. And then it is basically a sum of all of the orders, because all of these guys get activated by the query and put their signal onto the wire at the same time, so they get summed. And so now we get the sum of all the items there, and then we can feed that into the warehouse and make it part of the general order. So this is the general order here. And yeah, you can see it matches the sum of all the orders we're seeing. It also has that A value, and I'm setting that through a constant combinator here. You can make your manual adjustments here on top of the order that's coming in. A means all, so basically like add 100 to all items in the game. And this is like but 40 less of copper from that 100 addition, and also whatever is coming in otherwise. So yeah, it supports negatives. You can I'm pretty sure that A can be negative as well, and yeah, these can also be negative if you want to change how this works or whatever, to use negative for whatever reason. Yeah, so that's pretty much it. Let's do a real quick trace of it making a query. So we want to watch for this guy to get a signal. Should be on red. Oh, there, we just missed it, sorry. That's okay, we'll trace through. Let's see, it should be, well, let's just get another one. So the next train comes here. Okay. So let's not miss it. Okay. So T77. And we can also check this one. It's a mixed door 4. So I believe that's this one. Mixed door 4. And then, yeah, T77. So this, you can see the red-green network. It's on the red one there. So that means it's going to go to this pole, and then you can see that's going up there to these guys up here. So these guys are going to get the signal, and then there's some stuff over here like filters out the the virtual signals and stuff, and compares the. Eventually, these are basically comparing what the query is to what's being stored here. And you can see the query is T77 against T77. Oh, I'm sorry. T77 over here. So yeah, T77 against T77. And then the extra items will be made available to the green wire after it goes through all this. So just kind of step through, yeah, see the first layer there, and then it goes through each layer, and then eventually gets here, and then it's going to be making its way back to this guy, so it's going to come out of this one eventually. Yep, there it is. And yeah, now we see that on the green wire. And we can see that it's only coming from this one as we look at one of these other ones. See, this one's not lit up. Nothing's coming out of that one. It is getting the input because it went through all of these, but because of the other stuff going on, it prevents it from coming out of the combinator there. So this one has an output, this one doesn't. And then if we go over back to here, so now this, let's see, yeah, so now we're getting a response there on the green wire from there, and then this is gonna feed it back into the query here, which will kind of receive that response. It's happening over here somewhere, yeah. And then it will kind of register that as matching. correctly, and it'll store it right here. So we'll see that in a second. Yeah, so it's there now, and it's turned green, indicating that it got a value successfully. There's our order, and then yeah, now that we have an order, the train can continue, and then it goes ahead and stores it in the loader. Okay, and then one last thing I wanted to show here. Let me delete this first. So this is demonstrating how the collision detection works on the query objects. This is the same thing you were seeing down there twice. Here we have 3 of them, and they're all hooked up to the same kind of parallel thing, so that they get a trigger to send a query at the same time. And they're querying against some stores over here. And again, this matches the things down here in form. And then these are the different values. It doesn't really matter. So yeah, let's go ahead and trigger these, and you'll see that these are gonna collide, and when they collide, these lights will turn red, and then it'll try again, and on the second time, probably they'll all get it, because they have random back off, and each one has a different random back off, and so that means that when they try the second time, unless it's like 1 in 100 chance or something, it'll not collide the second time. And if it does happen to collide the second time, it'll retry and it'll work the third time, hopefully, or eventually. So let's see what happened. So red, and then green. So if we slow it down a little bit, let's slow it down. Okay, and then let's do it again. It's yellow, red, and then green, green, green. So yeah, that shows how that works. Well, it's really hard to move like this. Up here is where the, here, let me do it again. You can see this guy going up, and there's a count here that it kind of compares against for that. So up to 93. And then, yeah, if we do it again, did these finish already? Yep. So now it's doing like 109, blah, blah, and there's like a little simple random generator here. And I didn't make this, just a simple one from I think the Factorio subreddit. And okay, let's go back up to normal speed, and then I will show you what happens if you create them all at the same time. So they're actually gonna keep colliding over and over because they have the same random number stream because they were created at the same time, which means you have to introduce some entropy, which you can do by just feeding this thing any value. So maybe you want to do a railroad signal or something that'll be, sort of randomish, or if you want to get fancy, you could do something with an accumulator and a solar panel or something. And then these other guys are still going to be colliding because they didn't get entropy. So if we give one of them a little entropy, then that'll throw it off enough to resolve. And then the other one isn't colliding with anything anymore, so it'll resolve too. So yeah, that's how the collision detection works. Thanks for watching.